Hello and welcome to today's webinar. It's on choosing the right platform for your industrial IoT strategy. My name is Jeremy Cowan. I'm editorial director and co-founder of IoT Now, and it's my pleasure to be your moderator today. Thank you to everyone for joining us right around the world. We've got a great discussion for you, brought to you with our friends at PTC. So the first thing to do is introduce you to our speaker. I'm delighted to welcome someone with a wealth of IoT experience, Rob Patterson. He is Vice President of Strategic Marketing at PTC. It's great to have you here, Rob.
Thank you, Jeremy.
Well, today we are going to look at the audience's industrial Internet of Things strategy. Let's shorten that to industrial IoT. It's much less of a mouthful. And what we want to know is how to choose the right platform. Many of you will be familiar with the way that our webinars work. This is being recorded and you can access this tomorrow at iot-now.com. As many of you will know, our webinars are always interactive. So do start sending me your questions right now, and you can continue doing that throughout the presentation. After Rob's spoken, I'll put your questions to him. Just click on the questions button and type yours into the window. I'll put as many questions to him as time allows, and of course any that I don't get to will of course be passed to PTC to answer offline. And a selection of PTC slides will also be available after the webinar. Finally, if you're having any technical issues with audio or with your slides, you can also use the question window to get advice from our excellent tech support team. Now I'm going to ask Rob to start with a high-level view of PTC. Rob, over to you.
Yeah, thanks, Jeremy. It's really great to be here today with everyone. So, I'm really excited today to talk to you about not only just our platform, to really get you thinking about if you're embarking on an industrial IoT strategy inside your organization, what are the different components and pieces that may be most important within that process, but also might be critical within that process to really derive data from your equipment, from your machines around the organization and around your facilities to really inform decision makers and inform the technologies within your ecosystem and users within your ecosystem about what's going on within your industrial setting. So before we kick things off and get things bearing towards industrial IoT, I wanted to quickly introduce, PTC as a whole, because there's many different aspects of PTC and what we cover. But I think many of you may not know this, but the world, has fundamentally changed. I think what we're seeing now, especially in the industrial space, is something that hasn't really been seen since the 17th and 18th century with the Industrial Revolution, especially here. I know we're talking to a global audience here, but especially here in the United States, in that things have fundamentally changed in the way we interact with physical objects within our world. So what we're seeing right now is, because of many different things, whether it be lower cost hardware, more efficient software, but the physical and digital worlds have converged. Prior to all of these new technologies becoming available, a product was typically designed in a digital environment and then sent off to live in the physical world, where you could potentially plug in a USB drive or USB port or have some local area network connections where you could get some feedback on information. But things have happened so rapidly that now we're able to create very small sensors at a very low cost and place these items around an industrial environment and really get information at a very granular detail as to what's going on within an ecosystem. And really, at PTC, this is where we concentrate on, and it's really creating not only technology platforms that enable all of this to happen and enable that flow of information to happen from your equipment back to your users, but also solutions that make it easier to not only design but service and operate products around your organization, whether it's in an industrial environment or whether it's in a work site or a mining facility. It's really delivering the appropriate software and technologies that are needed for making it easier for organizations to service, operate, and design products. So, Jeremy, before we dive into specifically the IoT platform and some different aspects as to what all of our attendees should be thinking about, why don't I turn it over to you to run a quick poll in terms of what everybody's thinking is most important to them within their IoT ecosystem.
Yeah, that makes sense, Rob. As I said, we like these to be interactive. We really want your views. So we would ask you just to click on answer A, B, C, D, or E, whichever is closest to your experience, and obviously we'll see the results immediately afterwards. Your replies are, of course, anonymous, and the first poll question is, what's most important to your IoT initiative? Is it A, connectivity, B, data storage, C, analytics, D, device control, or E, all of the above? What's most important to your particular IoT initiative? Connectivity, data storage, analytics, device control, or all of the above? Well, hopefully you've had a chance to give us your verdict on that. Let's have a look and see what the results are. All of the above comes in at 33%, and I guess that's probably in line with expectations. Would you say so, Rob?
Yeah, I agree with that. And actually, I kind of knew that was going to be it was kind of a softball question, if you will. It was an easy one to answer, but I was more interested to see what actually came in second and third. And actually, my predictions were correct around connectivity, and analytics plays a big role within an IoT platform, and we'll be talking about that in great detail today, along with different types of connectivity that you need to be thinking about in your organization. So I think that's great. And before we dive in, just real quick, some covered slides so you guys know who we are and where we sit in the industry. So one of the things I wanted to get clear was PTC is the company or the holding company that has those many different solutions and platform that we talked about earlier in the presentation prior to the poll. But I think it's clear to understand that ThingWorx is the technology platform that powers industrial IoT within the PTC product portfolio. So if you hear me use the term ThingWorx, I'm talking about the underlying technology platform. If I use the term PTC, I'm talking about the solutions and platform as a whole within a company. So just keep that in mind as I'm moving through this presentation. But I think you'll see a lot of outside firms, including the slide you see here with Forrester, have really ranked us as one of the leaders within the IoT and industrial Internet of Things platform space. So if you look at this current slide right here, we're definitely up in the leader section within this particular graph. But you'll notice that our current offering in terms of completeness of platform, in terms of what you would need to embark on an industrial IoT journey, getting back to the poll question, which is all of the above, we provide all of this within our ThingWorx platform and our ThingWorx stack. So, and many companies are using this, whether they're, using this within an industrial setting to maximize their operations. You can see all the different types of companies here that we work with in doing that, or companies that are actually building products and building software technologies and embedding our platform within their offering. So we work in many different spaces, both in the industrial space, but also in what we call the smart connected product space, where companies are actually creating products to access different markets and placing those products in the market and gathering feedback from them. So we work in these spaces. But to be clear about IoT, IoT is really, like I said earlier, something that's really disrupting, not disrupting, but it's an evolution in the industry and how, especially in the industrial space, how we're doing business. And I think that when you look at it, it has the potential to fundamentally shift the way companies operate and do the business. So, and today it's a significant growth opportunity, especially for companies that are not only creating smart connected products, but within their organizations trying to streamline operations, whether it's maximizing opportunities or minimizing risks within their industrial organization. A lot of them are creating new ways to generate money, but also implement cost savings within their organization. So within their organization, I think when you look at all of the different departments that can be impacted by IoT or have some type of impact on operations or on the products being created, IoT really spans everything from operations to finance to engineering to sales, and especially service around what can be done from looking at product information coming off of actual equipment and actual devices and how to service them, things like predictive maintenance and remote service, all things that really are enabled by IoT. Every department within an organization is truly impacted and has an impact on what can be done with IoT in their organization. Now, the business opportunity created for the organization as a whole is tremendous. So if you look at all the different things that can be impacted, four of the things are represented here on the slide. There are many more, but I think the improved customer experience, so when a customer is actually using the technology, or a customer may be somebody inside your organization that's an actual user of an application that's looking at more of an operations focus, but improving the way that they can interact with their actual devices within an IoT, an industrial IoT setting is very interesting and creates enormous opportunity for users of that technology. And through that, they can optimize business processes and really, if you're looking at how we create smart connected products, you can really create a differentiated offering. So within your industrial setting, if you're creating an actual product and delivering that product to market, having that product become smart and connected creates a very differentiated offering for that product when it enters its actual place of operation. And then finally, with all of this, whether it's from a cost savings perspective or whether it's from a new product line or modifying an existing product line, it really allows you to generate new revenue opportunities, both from a net new standpoint, but also from a cost savings standpoint. Now, sounds easy, but there obviously are huge obstacles to actually implementing this type of strategy and understanding how to derive the value from what's being created within either a smart connected product or within a smart connected operations setting. So, a lot of people are new to IoT, and really they're looking at how to get started. So, where do I start? What should I do? What should I be analyzing? What products would be most beneficial to be connected? So all of these things there's a lot of strategic conversations that need to go on around IoT. Everybody knows that they want to do it, they need to do it, but they don't know how to do it. And I think that these are all things that are, potentially can shape and mold what an IoT strategy looks like and needs to be looked at very carefully by organizations. Now, when you finally decide how you want to go into it, finding the necessary resources that understand the complete stack and how to integrate the complete stack can be extremely challenging. So you have to go out and, getting back to our poll question, who understands connectivity? Who understands basic analytics? Do we have a data scientist that understands complex analytics and advanced analytics? Do we have somebody that can build a UI, UX framework for interacting with the actual devices through our application or through our product? So all of these things need to be considered when you're looking at how do we start creating the actual product or creating the actual application to deliver value from an industrial IoT setting. One of the things, and I'll talk about this a little more in a future slide here, but a lot of organizations look at, well, I'm going to build this myself, and that's fine, and you can do that. There may be a longer runway in terms of actually deriving value from doing so, but think about the ongoing maintenance of something that's not fully integrated and not meant to actually work together. You have turnover within your IT departments or turnover within your developer ranks inside of your organization. All of this stuff and all that knowledge needs to be passed on. So when you start patchworking technologies and technology stacks together, it becomes very difficult to progress and modernize and really deliver new versions and new pieces of technology to further what's actually being done from an operations and from a product perspective of your offerings and market. Again, talking from a technology stack perspective, not having full insight into how actually things are being used because of the fragmentation of the stack is difficult to, anticipate and really understand how to develop the technology further going forward. But, the biggest thing is that creating one application instead of having the ability to take the same amount of time to create one application and deliver multiple solutions that can impact many different organizations or many different products within your offering suite is difficult to do when you don't have a fully integrated stack that makes actual development easier. So when organizations look at how to really tackle these challenges, it's really three things. It's, do we build it ourselves, which I just talked about in detail. You can create it from the beginning with your particular needs in mind. The thing is, it's costly and it requires really skilled personnel to piece together the stacks that is needed to really deliver that full connectivity, device storage, UI, UX, analytics, all the things that are really needed from a technology standpoint to deliver true value from an IoT solution. The second might be, if you're creating a smart connected product, why don't we acquire a technology, whether it be some type of competitive technology, or go out into the market and look at actually acquiring a stack. But this is very difficult to do. It's very expensive, and there's risk associated with this, because you're looking at, from an acquisition standpoint in developing the technology, there's not only costs from a technology perspective, but there's operational costs as well associated with that. And the final one is, which is a lot of companies are embarking on, as you can see what we deal with at ThingWorks and with PTC as a whole, is a lot of companies look to partners. So how do we take a partner approach to adopting an IoT technology stack to eliminate the issues associated with building it ourselves and saving some money from an acquisition standpoint, and really acquiring other companies and integrating that, not only technology but business processes and organization, into a current organization. So, Jeremy, I'm gonna send it back to you, because I think that this is going to be an interesting question, and this will kind of shape and mold how I go forward in the presentation a little bit. But why don't we run this poll right now before I start diving into more of the technical stack and how we see the world as far as what's needed to really develop and deploy a true IoT solution.
Yeah, it's a good moment to look at it after your assessment of self-build, acquire, or partner. The question here in the poll is, how do you plan to deploy applications? And the options we've given are mobile platform, web, desktop, augmented reality, or all of the above. How do you plan to deploy your applications? Is it via mobile platform, web, desktop, augmented reality, or all of the above? Let's go and have a look at the results. Again, a very strong response on all of the above, 33%, but a very strong performance by mobile platform, either as the lead or the only answer. Was that something you expected, Rob?
Yeah, it is, and actually, given that this is a very industrial-focused session, I can understand why the web, and actually the web, if you're deploying an HTML5, can be used on a mobile platform. So that's not too unexpected why they're tracking pretty similarly, if you will. But yeah, it's completely expected that we're going to need multiple deployment methodologies, and that all of the above really ranked as the highest deployment methodology, because companies are going to want flexibility, right? When you're building a application or a product that's going to contain an application and deliver that, you're going to want ultimate flexibility as to where that app can be used, whether it's on an iOS device or an Android or a Windows mobile device, or through Safari or Chrome, or through a different type of web browser technology. It's actually interesting the desktop is so low. I thought that would be possibly a little bit higher, just given the industrial settings where a lot of deployments of these technologies are on premise, and they're stationed potentially at pretty siloed workstations. So, I think I think what we can derive from this poll, Jeremy, is that flexibility is needed in terms of how things need to be delivered. So this is good. So I think that this will really shape how I go forward and talk about this. But the getting to the point where you can start deploying these applications can be very complex if you don't use a platform. So this is kind of, whether it's for a fixed application, a mobile application, a custom interface, or even you can talk about a augmented reality interface here using our AR tools contained within our technology. But Getting back to the DIY aspects, and even from, even if you acquire and go out and buy multiple technologies and try to put them together, you're still going to have fragmentation across everything that's needed. So if you look at the stack from the bottom up, and I'll talk about this in a little bit more detail in the next slide, but everything from the connectivity layer to how data is being modeled and stored within your architecture, through to how are you doing things like controlling, pushing software updates, doing analytics and providing the insights into that as analytics through a UI UX experience. All of these things, if you don't have them, are extremely difficult to do. And it's getting back to everything we talked about a little bit earlier. All the challenges associated with, it doesn't matter where you're deploying it. All of the above is what the poll question said. But whether it's on the mobile, desktop, an AR platform like HoloLens or ODG, or through a mobile web browser, if you're not using a platform, you have very complex programming, difficult to maintain and evolve. We talked about all this stuff. And then, having everything connected in back-end plumbing, I think, is an interesting point where it needs to be made around security as well, because it's just more interjection points of where data is flowing, where a potential bad guy could get in and either put malware into the system. And this is something in an industrial organization you definitely don't want happening, because you're talking about system control, you're talking about manufacturing line control. Things can really get messed up, and downtime can be caused by, or shutting down an entire plant could be caused by malware, which could cost millions and millions of dollars for an organization. So having all this stuff fragmented and pieced together is a dangerous, complex, and expensive type of proposition. But when you start looking at it from a platform standpoint, you can really get to some more tightly integrated and fit together technology stack, where you have edge software that can connect out and provide a way to access the sensors, devices, different pieces of equipment on the shop floor, things within your shipping fleet, all these different types of data streams, if you will, that need to be integrated back to a device cloud. So a device cloud is essentially where the model and the data lives of the actual physical object. So digital twin is kind of a term that's been out there in the market, and essentially what a digital twin is, it's a digital representation of the actual physical object based upon the sensor data and data streams that that physical object is producing. So you're able to apply business rules and you're able to apply logic to those data streams and really create a digital representation of what the physical object looks like and provide that data in real time back to the application that's being used within the IoT stack. So, we feel at PTC with our ThingWorx platform that it's important to be able to have this model and this data live in anywhere that the application developer or the organization wants it to live, whether it's in our own device cloud, whether it's in their own data center, whether it's in AWS, whether it's in Azure. We have the ability to integrate that piece of our technology stack into any number of different sites and cloud storage methodologies that an organization might want to use with their own IoT initiative. So once you have that data modeled, how do you provide the information and how do you provide it in a way that a developer can take it and build a meaningful application, whether it's the web app, mobile app, desktop application, or AR application, but it's something that we call in the market application enablement. So how do you deliver the tools that enables a developer to deliver an application to an end user? So providing those tools within a platform setting really eliminates all the plumbing that's needed to maybe layer on a UI UX tool on top of a core piece of technology that's modeled back to the actual edge devices on a network. And then finally, things like utilities like device management and integration back to enterprise systems, ERP, CRM, SCM systems, all of this stuff is really tightly needed to be tightly integrated into your IoT stack so that you can provide not only the linear flow of data, but bidirectional flow of controls back to the actual edge devices and back to actual systems within your organization. So, all of these things are really needed from a platform perspective, and having the platform simplifies a lot of the complexity that we talked about previously in the presentation. It reduces the time that's needed to actually create a solution or create a product, and it also delivers a lower cost of ownership, and it allows you to do things like have more flexibility with updates, create easier new features within new versions of your product or within your new application. All of the things that are introduced from the complexity of having multiple piece parts to deliver a solution is completely exonerated by having a tightly integrated platform that delivers this stuff to market. So what we deliver at PTC is a holistic platform through our ThingWorx technology. And everything we just talked about, and I talked about a why and what's needed within an IoT stack, is represented within our ThingWorx technology. So let's start at the bottom of the screen here. Industrial connectivity. So I think that this is really important for, especially for this audience in the industrial setting, is our ability to use, so PTC as a company, like I talked about at the beginning of the presentation, owns many different technologies and develops many different technologies for better creating, servicing, and operating products. And one of those technologies is called Kepware. And what Kepware is an industrial connectivity suite that creates protocol drivers to connect directly to industrial equipment, whether it be Siemens equipment, GE equipment, Mitsubishi equipment. The list goes on and on. I believe there's about 160 different drivers out there for many different pieces of equipment, and is able to extract the data in its native form and aggregate it at a server level and feed it into our Thing model, which I'll talk about in just a second. But having that native connectivity makes it very easy to get information off of the core machines in an industrial setting and provide it back to developers and to applications and users that are ultimately using the products and apps that are being provided by on top of our platform. So not only do we have the industrial connectivity, but if you move a layer up on this to the edge, having all of the support for industry standard connectivity out to edge devices and doing the same thing that we do for the industrial connectivity, but to many different sensors and data streams and pulling it back into our Thing model. Now, where we store this, we can store it within our device cloud, or we can work with AWS, Azure, many different cloud-based solutions as well to model this whole platform in that cloud environment if that's the architectural decisions of a company that's either, again, building a product or looking to place this within operations within their organization. And I think this is an important place to note, and I always get this question when I do these sessions, is where should we be placing our technology stack from an IoT perspective? And I think, if you look at, my answer to that is, where do you want to place it? There's many different factors, whether it be security, costs, that go into that decision. But I can say that the majority of our customers that are using ThingWorx within the industrial setting are actually deploying this on-premise in their data centers or within their VPC environment to keep it behind their firewall. So when you're talking about things like device control and potentially shutting down manufacturing lines, a lot of companies want to know that that stuff is secure, and they feel most comfortable having that behind their firewall. Now, that being said, security is getting much better, especially with things like Azure and AWS. So we may see a trend over time to those things just going to many of the public cloud vendors, but we'll see how that happens over time here. So sorry for that tangent, but I think it's back to once we talk about the device cloud where things are going to live, now how they're going to live. So within our technology stack, we have something called the Thing model, and this gets back to the digital twin concept that I talked about earlier, which is how do we model the actual physical object, apply business rules, apply logic to the data streams coming in to make it look like a physical object in a digital world. So we do this through our Thing model. And what the Thing model is, it's really, I always tell people to think of it as a hub of data and a hub of information with many spokes off of it that the different component pieces of the ThingWorx platform can access and can use, and provides one version of the truth of data from that physical object to the digital world. And from that thing model, you can do things like analytics. You can create applications and UI, UX interfaces from our application enablement layer. And you can also provide augmented reality experiences through our ThingWorx Studio, information coming directly from the Thing model. Now, tied to all of this is the ability to do device management through our utilities, but also provide information back to enterprise systems through our different connectors, whether it be to Salesforce or different ERP systems as well. So again, having this holistic ThingWorx platform and delivering it to market really gives developers and gives organizations a quick way to do everything from native connectivity all the way through to developing solutions. So at its core, what it really is, and I'm not going to go through this, but it enables organizations to build things really fast. And why it enables the organizations to build things very fast is it has all of those pieces integrated back to that Thing model, which is the hub of what's being seen in the actual physical world back to the digital world. And this enables developers, whether it be your product engineers that are building products to deliver to market, or maybe an IT team that's building applications for internal use, to build a lot smarter and to build applications that are really rich in features and really rich in their ability to deliver and derive information from raw data, many different data sources, in a meaningful, contextual way to end users. And then, finally, I think what's really important is there's a lot of IoT platforms on the market. I think at last count, I think we're over 700 different IoT platforms in the market at this point. But not many of them are built for scale, and not many of them are really built for what we call built for enterprise. And I know that this can be a buzzword term, but having the ability to scale in a very secure way and deploy things the way that organizations want to deploy them based upon their architectural decisions within their organization is something that we provide through our platform. So I talked about all the different component pieces, and I think that having the different things, whether it be the Kepware, whether it be our foundation that provides everything from the edge connectivity through to the application development, our studio for AR, our analytics, and our utilities, having all this stuff more tightly integrated allows organizations to do some very interesting things. And there's benefits to adopting a platform like ThingWorx, whether it be the ability to connect to almost anything, to analyzing, to quickly implementing data, managing actual devices in an organization, and providing new, more meaningful experiences for end users. Our platform provides all of these different pieces, and really when you're starting to think about, what does an IoT platform look like? What should we be looking for? It's all these things that you see here on the screen that are provided through our platform. And this is just a different view of this as to what pieces of our platform provide the ability to connect, analyze, implement, manage your devices and experience things in a new way. So I wanted to quickly shift now before we open up for questions to talking about analytics, and I think this was second or third, I can't remember exactly, most important thing in our poll earlier in the presentation. But whenever you start talking about IoT and industrial IoT, analytics is a topic that comes up probably within the first 15 seconds of talking about it. And really, it's getting down to how do you create meaningful, contextualized information out of many, many different raw data streams coming into your platform. So when you look at it, there's many different types of analytics, whether it be descriptive, diagnostic, or explanatory, and then getting to more advanced things like predictive analytics and all the way through to prescriptive analytics, which is a topic that a lot of organizations are not even looking at this point in terms of how they're and what they're implementing inside of their solutions. But when you look at this is something that, through our ThingWorx analytics piece of our platform, we offer complete end-to-end coverage in terms of being able to do this from a data perspective. And the reason you want to do this, especially when you're thinking about what IoT platform implement, is, analytics is really at the core of what IoT is. It's we're not creating data streams just for the sake of creating data. We're creating data to turn it into really actionable intelligence and real-time intelligence for organizations to be able to determine what to do to maximize opportunities, minimize risks, and ultimately further their businesses and grow their bottom line. So what we're seeing in the market is actually something pretty interesting, that the analytics aren't actually integrated into the apps they're using. So there's an IoT solution, but then when you want to get advanced analytics like predictions, or even run some simulations potentially through an application of what to do and what not to do in a certain situation, you have to go to another tool. It's not really integrated into the solution that the users are using, and it's creating this intelligence gap that we call it, that exists between an IoT solution that's built on top of a platform and actually the translation of raw data and information that's contained within the analytics tool. And that's really what we look to provide, with our platform. And really the essence of the ThingWorx analytics offering within the platform is the ability to really provide a new way and a new capability for data to be automatically translated into information within an IoT stack. So without diving too far into the technology, I can definitely answer any questions on the analytics piece of our platform. But it's really about being able to provide different ways to look at IoT data. Because I think if you look at historically the way data analysis has been done, it's always been point in time and user driven, in that the user is really the key part of the process in finding interesting things within a raw data set. We think that within IoT, because of the massive amount of data, the speed at which it's delivered, and the variety of which needs to be correlated, you really need to deploy machine intelligence to look at the data sets and really tell a user what's important inside of the data, instead of relying on the individual operator or individual user in application to analyze potentially billions of points of data to come up with informative intelligence and ultimately decisions based on that intelligence. So, we've deployed a few different pieces of technology, whether it be our Thing Watcher technology, our Thing Predictor technology, or our Thing Optimizer technology. But the key to all of this is an automation aspect. So the ability to automate very complex analytical processes, provide that analytics back into the applications that are actually being used by operators and end users, that's built on top of the technology stack, and close that gap that exists between existing tools, and provide a way that the actual applications that are being used within an IoT ecosystem can contain those analytics integrated directly into it. And this is all within our stack, integrated into the actual Thing model and integrated into the development tools, so that you have the ability to easily put this into the applications that are built on top of ThingWorx. So before I dive into the Q&A, and Jeremy, we open things up here, just a couple of case studies. So, Tech Mahindra has been using our platform for many years now. Actually, they've been a partner of ours. But, one of the things they're creating is smart building apps, so they're able to look at HVAC systems, remotely access different assets within a smart building environment and actually control them through the application built on top of ThingWorx. Smart insurance, so you're looking at real-time diagnostics of the actual fleet that's out there doing service, and then smart cold chain monitoring, where they're tracking movement and monitor the health, perishable, and shelf life of equipment. So looking at different things around the organization using our platform and looking at those data streams, taking the raw data, analyzing it, and providing users back information. Same thing with All Traffic, again, a user of our technology. For those of you that don't know them, they're a leading manufacturer of signs used by police departments and governments to understand and manage traffic. So really traffic monitoring for municipalities around the world. So they were able to provide an application that was built, and this is a smart connected products play, but provide an application that takes their core technology, aggregates all the data, and provides an app out to better understand, for the law enforcement professionals or the government agencies, the traffic patterns, different flows of traffic, everything that their core technologies from a hardware perspective ultimately deliver. All right, so I've been talking for quite a while. It's now time for you guys to talk. So Jeremy, I'm sure we've had some questions come in. Do we want to start cranking away and get to as many of them as we can?
Yeah, let's do that. We've had a good number of questions, Rob. As always, it's great to see the response. One of the first ones I want to get to is regarding the data processing. It says, is the data processed in near real time at your end? Consider that we have millions of connected devices and billions of data coming for processing. How do you manage the real-time analytics?
Yeah, so the real-time analytics is run in a couple ways. So, when you're talking about the analytical processes within our platform, there's two different, especially when you're looking at advanced analytics and our machine learning technology. The two different phases of that are the learning process, of which a actual model is built and which data can be scored through, and then there's the scoring process. The scoring process can absolutely be run in real time, and you can score data records. I forget how many per second you can actually score, but it's as close to real time as real time can get through our platform. But the training aspect of that, I think the training is very much point in time. However, the training can be looked against a validation set of data in terms of how it's creating a model and how it's objectively looking at the model that it's created and how accurately it's going to predict future outcomes or provide simulations based on the outcome that you tag within the metadata set that's being rolled into the Thing model. So there's two aspects to that. The scoring is real time. The model validation is continuous. The model creation is done at point in time, and the model creation, how long that takes, is based upon not so much the actual length of the data set, so how many records you have, but the different variability in terms of the different variables within that data set. So if you think of it as a very simple database, it doesn't matter how many rows you have, it matters more so how many columns or features you have within that data set, and that correlates back to how much time it takes to create that model.
Yeah, that was from an integrator, not surprisingly. This one is from a North American network operator. Rob, he's asking, should device management always be above the application enablement layer? I was under the impression, says the questioner, that for more security or control on your devices, it should be above the device cloud.
Yeah, so if you look at that diagram I should have clarified this during the presentation. That's not how the stack should be architected, absolutely. And I would agree that the device management should be behind the application layer as secure as possible. And actually, I think the utilities, whether it be the integration aspects into other systems or the device management capabilities, should actually be below or behind everything and acting as an actual utility that's facilitating everything within the actual application. So the way things that were laid out on that slide, and we've had actually this debate internally here as to how to lay this out, was more of a let's show everything, not so much let's show where everything sits within the stack. So I absolutely agree with that person that it should be further down the stack and actually behind the other applications and facilitating other things that are contained within the app that's built on the platform.
This is an interesting one about, I guess really it's sort of amortization and living with a platform from a traffic management company. Rob, he wants to know, are platforms risky? What happens if the platform is depreciated or loses support in the future?
Yeah, I mean, that's a risk with any enterprise software, right? So, the risk with using any enterprise software, whether it's an ERP or any, it can eventually go away. I will say that this is an emerging market. There's been a lot of consolidation in this market. There's been a lot of change in this market, and the reason that we sit near the top of capabilities and near the top of the market of 700 plus platforms, we're continuously in the top 3 or top 4 of all IoT and industrial IoT platforms in the market, is the fact that, one, we continue to invest in our technology. We're definitely not pulling back in terms of how we invest in research and development and continuing to develop the features within our technology stack. But we at PTC think that we're in a fundamentally different spot versus other platforms in that we have a rich heritage in terms of product design through our CAD software that we're able to, when we talked about way back at the beginning of this presentation, the convergence of the digital and physical world. When the products were once designed in the digital world, we provided that software that designed those products for the most part. Our CAD software our CAD or our product lifecycle management software has something like 40,000 customers that use our software globally. So we have a rich heritage in not only the product design, but now the platform that can take that product when it actually lives in the digital or physical world and provide information back to the actual developer engineer that's building that product to better further enhance that product experience. So I think if you look at it back to the point of your question, it's a risk with any enterprise software, whether it be a technology stack or an actual application or solution. But from a PTC perspective, I can tell you that it's not going anywhere. We're not doing anything with it. We're continuing to invest in it because it's really the mission of our company to provide that holistic feedback loop and can really connect the digital and physical world.
Interesting. There's a couple of comments, and these aren't either of them questions, but I'd be interested in your point of view on this, where two people have commented on the initial poll that we did. What's most important to your IoT initiative? One said security is missing, and the other said that customer experience is the number one for them. What's your thoughts on that, Rob? Because, both are critical issues. Are they things that should be thought about at that initial phase, or do they play in later?
Yeah, absolutely. And the reason we didn't include them was we couldn't put 7 or 8 different options on the poll. But no, security is definitely something. And when you start, I think I said, when you start talking about IoT, especially in the industrial space, that analytics comes up 10 to 15 seconds into that conversation. Security comes up like 5 seconds in. So it's normally near the top of the list in terms of, how to secure an IoT solution. Security is something that's always evolving because if you look at the way that, I always call security, especially in an architecture stack, as a chess match with the bad guys, because you can close up a hole, which they're just going to attack another one within your platform. It's really hard to get to 100% coverage from a security perspective, and really that's the reason why a lot of people put it behind their firewall, because they get the benefits of all of the protection within their organization behind their firewall, not risking a public offering. But security is always something that's very, very important, especially within the industrial space, and I hit on it at a couple different points within the presentation, talking about why certain things are deployed in some spots, and different ways that security should be thought about within when you're considering an IoT solution. And Jeremy, I'm sorry, what was the other one?
UI UX experience.
Yeah, so customer experience is paramount, especially when you're talking about. I guess you could say also when you're, definitely when you're creating a product. So you want to have a product that really looks good, that you're able to update continuously. So yeah, customer experience is definitely a very important aspect. And we feel through our application enablement layer that we give the tools to a developer or UI UX designer to create really strong user experiences, because you have to have a strong user experience in order to drive customer satisfaction. So having that core technology integrated into our stack, we feel that we give developers that capability. When you're talking about enterprise operations, it's not much different, because you're not going to spend IT resources on creating an application that's not going to be used. You still want to have an app that's meaningful to end users. And again, providing the tools to do that within an integrated stack is something that we take very seriously, and actually is one of our key differentiators in our technology stack is our whole AEP layer that enables a developer or designer to build those applications rapidly.
Yeah. You talked a little bit about this earlier, Rob, but I'd love to get your view on this. One questioner wants to know, should IoT application providers be thinking about a future with more data held and analyzed at the network edge?
Yeah. So I didn't touch on this today because we didn't go into analytics in too much detail, but Yeah, edge analytics is an interesting topic that's starting to bubble up now, and primarily it's starting to bubble up because there's a couple of converging factors and things that are going on in the market. One, the data that's being created is just getting too expensive to store. There may be value in that data, but what's the cost benefit of storing that data? And two, I think from a convergence standpoint, the availability of compute resources that can actually be put out at the edge of the network is getting greater and greater. So if you look at companies like HPE or Dell or Lenovo or ADI and Intel creating and National Instruments, any of the companies out there that are creating edge devices, these edge devices are getting very, very powerful. So the amount of compute that you can actually do out on the edge is becoming greater and greater. And as that becomes greater and greater, the analytics capability that's going to be available out at the edge is going to become greater and greater as well. Now, at the same time, I think what needs to happen is the software needs to get more efficient and running out at the edge. So doing things like when you're talking about training or creating a model or an ensemble model for things like predictions or simulations or prescriptive analytics, the software needs to get better at smart sampling the data stream. So how do you not take all of the data, but how do you only take pieces of the data and really create those models in an accurate way? So I think that edge is something that is very interesting, especially in industrial settings. So, it always comes to mind an oil refinery or a downstream oil process, whether it be a rig or whether it be some type of refinery that could potentially have millions and millions of sensors that are creating valuable information. How do you analyze all of that information and pull the value back? Well, you're not going to store all that data, but all the processing could be done out at the edge at this point. But I think we're at the infancy in terms of like I said, the compute power has gotten better, but it's not what you can do in a data center, and it's not what you can do in a cloud environment in terms of hardware horsepower. So as that continues to get better, you're going to be able to do more and more out at the edge. And also, there's getting back to the security aspect, there's many advantages from a security standpoint of doing things out at the edge versus having to funnel data back to a cloud or to a data center where there are potential injection points for malware or for bad guys to intrude into data streams that are being transmitted back to a storage facility.
Okay. Well, bringing things back from the edge to the core, questioner here says, if a customer operates in more than one industry vertical, and they give the example of medical devices and life sciences, does the ThingWorx platform integrate data from multiple industries, or is the data separated?
No, it can integrate data from multiple industries. I think when you look at the data streams that it can read, it's agnostic. It doesn't matter what type of data it is, and I think that that's one of the values of the Thing model, is the Thing model can be created, and rules and configuration can be applied to that Thing model to make the digital twin of the actual physical object be whatever you want it to be based upon the data streams that are coming in. So it's definitely agnostic in terms of industry. It's used in everything from healthcare equipment, whether it be MRI machines or actual physical beds that are used within a hospital, through to things like manufacturing lines and industrial equipment like pumps and oil rigs and those types of things. So it doesn't matter where the data is coming from. The platform is completely agnostic in terms of what it can connect to and what data can be modeled and applications ultimately build on top of.
Yeah. We've got time for two or three more questions, but probably that's all. So there's a question here from a consulting company. What kinds of devices and connectivity are supported by the platform? How do you access and control devices that are, quotes, behind the gateway, unquote?
Yep. So this is well, the second part of that question we should follow up on afterwards, because there's more detail that I would want to get into with that. But I think if you look at how we access, so it's done through a couple different potential options. One is the support of going out either through one of our edge connectivity options and pulling data streams back to our Thing model. Through that, we support the industry standard protocols to get data back to our Thing model, but also, especially in the industrial setting, this is where the Kepware technology of being able to look at native data streams off of shop equipment using those protocol adapters come into huge value for developers on top of using our platform, because you can easily connect to those devices and get that information aggregated and back into the Thing model within just a few minutes of actually deploying it. So, there's much more detail that we can provide behind that, but it would be good, Jeremy, if we can follow up on that one after the session.
Yeah, I'm sure we can. Another one from a similar company. From your point of view, what are the most relevant features within device management? And the questioner lists firmware updates, remote control, etc.
Yep. So all of the above. I'll answer on that one. I think they're all important. The two that are particularly, especially in the industrial setting, that the majority of our clients use are the device control, so creating a bi-directional aspect of an application that's being built on the platform. So not only being able to consume the information coming off the device, but being able to control the actual device. And then the other piece I think that often gets overlooked is the ability, well, two pieces, is the ability to push out updates to the actual devices and machines through the application, but also the integration aspects back to systems of record in the organization. So things like ERP, SCM, different CRM, so whether you're using SAP or Salesforce.com, integrating the information from your IoT ecosystem back to those systems of record, keep those systems of record inside of your enterprise, if that makes sense. So instead of having two places to go for data, you can still keep what you're currently using and have that information integrated back to your systems inside your enterprise.
This is a short question, but I suspect an enormous answer, so I'm going to ask you to confine yourself to 30 seconds if you can, please, Rob.
Okay.
What metrics on this one, what metrics are best to analyze for industrial IoT?
Wow. The way that I would answer this within 30 seconds is what metrics matter most to your bottom line. So and this again, and this gets back to, I think this is very much an analytics-focused question, is what do you want to see out of the data that's being collected from your IoT ecosystem or from your industrial equipment? So, this is where before any application development or before any connectivity actually happens, this is where you need to sit down with the people that are actually going to be operating the application, that are operating the devices in the ecosystem, and understand what's most important to them, and then take what's most important to them, translate that into, here's the data that we need, and here's what the information that we need to pull from that data in order to give them actionable intelligence through the app that we're delivering. So I think it's as much a consultative process up front as it is a technology aspect or technology process and gathering data and interpreting that data to contextualize intelligence for an end user. So, that is a very long-winded way of saying it matters, what KPI should be looked at is what matters to the actual operators or users within that IoT ecosystem.
That's very fair. There are more questions than we possibly got time for, so I'm going to have to wrap it up there, but we have got some great questions on return on investment, on oil and gas industry, and what I'll do, Rob, if I may, is forward these questions on to you so that you can take them up with the questioners directly and respond to them offline. It's been brilliant. I want to thank you for your generous amount of time you've given this, and the fact that you've been able to take on questions from almost any angle conceivable. I'm really grateful for it.
No problem. It was a pleasure to be with everybody today, and I think it's important when you're really getting back to the crux of this presentation, choosing the right platform for your industrial IoT strategy. It's really about choosing something that's going to enable you to secure your application and your data, secure your industrial environment, and provide a way for your developers to either create products rapidly or additions to products rapidly, or applications out to your organization that make money, save money, or reduce risk. So, again, really happy to answer any of those questions, and any of those questions we didn't get to, I'll definitely follow up with those.
That's great. The dashboard will remain open for a little bit longer, so questions are still coming in, which is great to see, and I'm grateful to all our audience for those. Any that we continue to get, we will, of course, forward to Rob. The aim of the webinar, as you can see, has been to understand not just how powerful an effective IoT platform can be, but actually to assess which platform is right for your particular organization. And I think it's fair to say in the discussion we've heard some of the challenges and a few things on how to overcome them. As I say, sadly, that's all we have time for. Please do remember to bookmark our website at iot-now.com. You'll always find the latest news there, plus blogs and events and interviews. And from tomorrow, you'll be able to stream this webinar from our site as well. It just remains for me to say a huge thank you to you, Rob.
Oh, my pleasure.
And most of all, ladies and gentlemen, I want to thank you for joining us, for sharing your opinions, and for all your questions. Keep safe, and we really do appreciate the time you spent with us. From everyone here at IoT Now, enjoy the rest of your day. Bye for now.